The topic is, I'll just put finding, come on, right.
Finding triangles using trig.
No, finding sides and angles. And I feel smart today, so I'm going to call myself Albert Einstein. I did that in another class one time, and they turned their paper in. It literally said Albert Einstein. They wondered why I took off 10 points. Aiden, you okay?
Maybe they felt like it too.
Yeah, I'm hoping he'll say.
Okay. So today is 3. Why am I writing 4 on anything? 3, 6.
We should do April Fool either.
Well, somebody messaged me on last Friday, and said, April Fools. And I said, LOL. Do you mean March Fools? And then I guess then they realized their faux pas.
What? No, anyways, your monitor's gonna be on top. Pretty good story.
You what?
I'm gonna make sure your monitor's on top of the thing.
What are you talking about?
It's just gonna be jammed in there.
Do you guys know what he's talking about?
For April Fool's, sir.
Oh, April Fools?
It's gonna be in the ceiling.
Okay, I can't wait to see that. So right now we're finding the value of x. We need calculators because we're literally going to round our answers to the nearest tenth. So I'm looking at this problem, and if you did the work from the sub on Monday, you will recall that what happened. And I had a couple people message me and remind, because they had letters, like they had an A. Why isn't it writing again? They're A, B, C. And they were asking me, what does A mean? Does it mean the cosine? I said, no. In geometry, you could label your angles with capital letters, right? And that would mean across from B would be a small b, that's its side. And across from big C would be small c, that's how you could name that side. And across from big A, you would call it the side A, right? So there's a lot of ways to look at a triangle. But in this case, let me get rid of that garbage because that was just FYI. I have a side that I'm looking for right here. And the only thing I have another side that I know, and then I have an angle. So your job is to say, using the unknown and 2 other pieces that must be known, what trig function would be related to this 32 degrees using the sides that I circled?
11.
What is the 11? What is it in comparison to the angle 32? Is it the opposite side?
Obtuse.
Opposite side?
No.
It's not?
Yeah.
It's not across the street from 32?
Yeah.
And then what is this thing called, the x? What is that called? It's called the hypotenuse.
Oh shit, I'm right.
So if only I knew a trig function that used an angle and the opposite and the hypotenuse. What trig function uses those? Sine. We don't want any sinning around here. Well, I mean, it's human nature, but we're supposed to avoid it at all costs. I'm just saying. The sine, and I don't put theta, because I know theta, don't I? What's theta? Hello? What is theta in this picture? 32 degrees must be equal to opposite over hypotenuse, which is equal to 11 over x. So what am I looking for?
For hypotenuse. Right?
Yeah, I am, which is called x, right? So let me erase this middle thing here so you don't get confused. So when I solve this for x, I'm going to do it only one time this way. I'm going to do it one time. The other times, I'm not going to do it. I'm going to go put a 1 under here, make 2 fractions. 1 fraction equals to a fraction. In the real world, we call that a proportion. When you were in middle school math, you were solving proportions where the teacher either told you to cross, multiply, and divide. But now I have kids saying, is that the butterfly? Yeah, it is. It's the butterfly. I guess because when you cross multiply, you can see the wings of a butterfly. So if I do that, what is x being multiplied by?
32.
Not 32.
Sin.
The sine of 32 has to be equal to what number? What number does this make? 11. So I want to solve for x, so I got to divide both sides by sine of 32 degrees, including the 11, divided by sine of 32 degrees. It cancels out. You're done. All you got to do is use a calculator. So pick up your calculator. Type in 11
it's 11.
divided by, where is sine at?
Control.
Nope. There's a little button on the left underneath the control key, trig. It's the best thing in the world. None of my other calculators had it so simple. Press trig and you see sine, cosine, tangent, cosecant, secant, cotangent. You even have some with the little ones in there. Do you see it? Sine to the negative 1, cosine to the negative 1. That's called inverse sine, inverse cosine. That's what we use when we find angles. The reverse is finding angles. I think it's cool. My calculator doesn't make it that easy. So please key that in and tell me what x is and round it to 1 decimal place. How much?
20.7.
I'm going to run with it because nobody else said anything. 20.7. Does anybody agree? Can I get a thumbs up?
Yes, sir.
I got some thumbs up. You're going to round it to 8?
Is it 20.8?
I don't know. What are the two digits after?
5 and 7.
No, 20. Read me your full answer. 20 point.
20.75.
Oh, yeah, I'm sorry, Anthony. We would round that to the 8. It's not a big deal. In calculus, I like his answer better. We call that truncating. I like it better. That way you won't make a mistake in rounding, because if you did everything right, but you rounded it wrong, you actually lose a point. If you just left it at 20.7, you get full credit. Isn't that great? All right, moving on, number 2. By the way, normally we'd have measurements. We'd have miles. We could have inches. But because they didn't give me any units, I just leave it as 20.8. So I'm looking at number 2. And here's my theta. This is my theta. And I'm given an unknown across the street from this theta. So what letter would I give x? H? No.
No, wait, no, it's 8.
No, because it's not touching the angle. That's the opposite of it. See, I even gave you a hint by drawing an arrow across the street. And then I'm given this 21, but this is the reason why the 21 is the A, is because it's literally touching the angle. You see how that angle 75 degrees uses the 21 as a leg? We call that adjacent because it is touching it. So what trig function uses O and A? Say it again?
10.
Tangent. So tangent of my 75 degree angle is equal to the opposite. What is the opposite?
X.
X. What's the adjacent?
21.
21 degrees. No, just 21. It's not degrees. So now I got to get the x by itself. So what has to move?
21.
How?
By dividing.
It already is dividing.
I'll subtract.
You mean multiply?
Same thing.
No, it's not the same. Same thing. So x is 21 times the sine of 75 degrees. Pick up your calculator. This is so cool of a lesson. It's like calculator does all the work. All you got to do is document what you're typing in. 21 times the tangent of 75 degrees, rounded to the nearest tenth. Please, x is? Who's sleeping over there?
I think it's 78.4.
Does anybody else think it's 78.4? Is it rounded right? Okay. No units. Leave it blank. Naked units. Naked. All right. Number 3. Maybe I should jump down to a harder one and say there is. If 5 or 6 is harder, I don't know. We'll do 3 and I'll drop down to one of those. So I'm looking at an angle theta right here. It's 23 degrees. The font wouldn't let it fit, so they just do an arrow to it. Notice what sides we're having. What is this called? It's across the street from the right angle. That's H. What is this one called? Sharing a leg. The what? The A, that's right. What trig function uses A and H? The what? You know, you could be a rebel. You could actually use secant if you wanted to. But cosine of 23 degrees is the x over 30, I think. Therefore, 30 times the cosine of 23 degrees must be my unknown side. Pick up your calculator, key it in.
Sir,
Yeah,
my calculator is a little bit different.
what's happening?
Every time I type in, like for the last problem, 21 times 1075, he gave me negative 8.5.
Okay, on the top right of the screen, do you see DEG or do you see RAD?
Right.
Okay, you're in radians.
Okay.
To turn it into degrees, you have to go to settings. Somewhere in settings, there's the angle measurement, and you can choose degree. See if you can find it. Did you find it?
No. Actually, I found it.
You did?
Yeah.
So change it to degrees and you'll be good to go. Good lesson that he just had. Sometimes somebody else might put your calculator in radian degrees because we're in radians. Later on, we will be in radians a lot. But his answers are off because degrees and radians have a conversion. So he thinks that you're doing 78 radians, which, my gosh, there's 2 pi radians in a circle. That's a 6.28. Can you imagine how many times you're going around in that circle to get 75? You can take, it's at least going to be like 30 different revolutions around the circle. It's crazy. That's why he's getting a negative answer, because he's literally in a negative quadrant. You don't know what that means right now, but you will.
Yes, sir.
Did you end up getting the right answer now for this problem?
27.6.
Oh, nobody told me what it was. 27, 20, come on, right. 27.6. Did anybody else get that? Were you able to get it, Daniel?
What?
Were you able to get 27.6?
I didn't put that one in yet.
Okay, let me know how it works. Let's jump to number 6. We don't have to do every one of them.
Yeah, we're.
Cool. I actually figured that out, the setting bit. Wow. You know, I don't use the Inspire. Everything I'm telling you is I've just memorized it by looking it up. I don't have the experience of using the Inspire because I have vision problems, and there's a lot of menus that are really small. So it really is hard to use. But anyway, I'm kind of feeling my way through like a blind man. All right, here's my theta right here. I am. I'm very close. Most people who have my problem are blind by the time they're 27 years old. Well, a lot more than 27, you know. Maybe 32. Yeah, right. So there's theta. What is this side called? What is the 25 compared to the angle? Nope. It's not A. It's the opposite side, so it's O. What's the X called?
X is H.
That's the H. What trig function uses O and H?
Oh.
Say that again. A and H.
O and H. Did I say A? I didn't mean to.
It's
You could say sine, but I want some of you to use sine of 25 degrees. I want some of you to use cosecant of 20. Quit talking over there.
H over O.
So if I use this one, O over H, that gives me 25 over X. If I flip it, I have
H over O.
that would be X over 25. So what I want to do is see if we get the same answers, because you're lucky. Your calculator has cosecant just as easily as sine. On the other calculators, you literally have to type in 1 divided by sine of it to get cosecant. Oh, I don't know.
18 degrees.
Where did I get 25 from?
From the opposite.
Oh, yeah, I see what I did. I'm glad that you're paying attention. 18 degrees. Thank you.
Next page.
And thank you. Type it in. Oh, wait, I got to solve it for X first. For this one, X will be equal to, I hope you see it, 25 divided by sine of 18 degrees. This one, X is equal to 25 times the cosecant of 18 degrees. So I hope some of you chose one and some chose the other. What did we get for those that chose sine, the traditionalists?
Whoa, traditionalist.
Yeah,
You're separating the class, sir.
I am. I told you to separate.
I'm a far right.
So what does that answer give me? Who did 25 divided by sine of 18?
80.9.
Anybody else get 80.9?
Yes.
How about the cosecant people? You guys that are on the other side of the track, you chose to be a rebel. And you use cosecant. So you had to type in 25 times the secant of 18 degrees. What did we get? What is X? 80.99 again then? The same answers?
Sir,
Yes?
we get pass.
Yes? All right. New topic. Caleb, read me this paragraph starting with given,
Given the
trig.
the trigonometric, the English value of an equal, use the corresponding inverse function.
Trigonometric function.
Trigonometric to find the measure of an equal.
So with your trig button, you actually have something called the inverse sine. Let me share what that means. It means if you're looking for an angle, right here, then the angle must be the inverse of the answer to sine. Inverse. Another word for this is arc sine. Arc sine. But a lot of people use inverse sine. Let me show you why this works. If cosine of theta is equal to x, and I say to myself, I need theta by itself, I got to try to find a way to cancel cosine. So what I do, both sides, I inverse cosine, both sides, including this side, inverse cosine. And the beauty of this, guys, and I won't do this every time, I'm just doing this once or twice to tell you that I'm canceling out cosine because it's like canceling out a square root. To cancel a square root, I square. Whoop, wrong way. I square. I square it and it cancels out. That gives me x. Same thing here, okay? So when I use the inverse cosine both sides, out pops out theta equals to the inverse cosine of x. Same thing with tangent. You drop in your phone?
No, I dropped my calculator.
It's not your calculator. That was too heavy for a calculator.
I know you hear from over there.
It sounds like over there. So to get rid of tangent, I inverse tangent both sides, and that gives me inverse tangent of x will be theta. And the good news is you have that button. So we're going to find angles rounded to the nearest tenth of a degree. So look what I'm looking at. I have two measurements of sides. Yes.
Can you scroll back up real quick?
Sure can.
Thank you.
You know, sir, back in my day, we didn't have computers.
No, that's not true.
What?
Back in my day, there weren't computers. Back in your day, unfortunately, they even had cell phones. You know, the first computer I remember touching was just a keyboard that appeared to be just plugged into this weird monitor, but there was no computer in the room. And the teacher took us all and we showed us how we could print our name, and it would come out from a big printer 3 rooms away. It was on a mainframe computer. We were like, wow. Didn't have a disk drive, didn't have nothing, you know. So moving on. There's theta. These must be the sides I need. How are they related to theta?
Excellent question. How are?
23 is H and 18 is A. What trig function uses that? The what?
Let me go look back at my notes.
A and H. Cosine. So I want you to realize that the cosine of my angle that I don't know, hey, this is what you did on the work for Monday. Cosine of theta is equal to 18 over 23. But I want theta. So what I do is I do inverse cosine of this fraction. Will give me theta. So now pick up your calculator, type in inverse cosine from the trig button, and put in the fraction 18 divided by 23. Hit enter, and like magic, your angle comes out.
38.5.
And should it have a unit? Degrees. Nice. Good job. You should be feeling powerful now.
I feel like I don't want to be at school anymore.
Caleb, you're just such a breath of fresh air.
Tell me about it.
So now, there's my theta up here. There's my theta.
Hypotenuse and your opposite, sir.
I have a hypotenuse and I have an opposite. What trig function is that? Isn't that a sine? I forgot that. Somebody left.
It would be very. Sine theta.
Sine of theta must be equal to what?
Opposite over hypotenuse.
What is opposite then?
5 over 21.
5 over 21. Therefore, the arc sine of 5 over 21 must be theta. Pick up your calculator, type in trig, inverse sine of that fraction, and press enter. 13.8 what? If you don't put degrees, the person's going to think you're in radians. And won't they be surprised? All right, let's see. I think we got more of those on the next page. Let's see. We do. So I need to do at least one more. Let's see my time. Oh, I got plenty of time. Yeah, because I don't plan on giving you homework today. You already have a homework to finish up. So, number 9. What trig function uses the 18 and the 17?
You have your
If you're if
and your adjacent.
you do. Opposite adjacent. So you either got to use tangent or cotangent. Most of us will stay pretty conservative and just use tangent. And if you're just writing these down because you're hearing somebody else, but you're not getting it in your brain why they're saying that, you are cheating yourself. Because this is not really that difficult. It's amazing. This is an advanced lesson compared to what we were doing, but it actually is easier. So I hope you keep that in mind. Well, you're seniors. You won't get to take calculus next year here, but. So you said tangent. So tangent of theta is what, Caleb? What are my fraction I'm going to write?
What?
What fraction am I going to write?
O over A.
Which is what? Fraction.
I'm not good with names.
Use the numbers, please. Well, I wanted Caleb to push through.
I can't push through for you, sir. You can't rely on me. I'm a failure.
Oh, Caleb, that breaks my heart. Because you know what they say?
Sorry, sir.
If you fail, then I failed as a teacher.
Ooh. No, sir.
Oh,
Don't
well.
be so hard on yourself.
Yeah. Thanks, Caleb. I appreciate
You're
that.
doing what my father ever did.
Manipulation.
Lord help us.
Don't be talking.
So if I inverse tangent both sides, out pops out theta, right? Will equal to the inverse tangent of the fraction. So pick up your calculator, go to arc tangent, which is the inverse tangent of that fraction, and prepare to be amazed at what that angle is. Looks like a big angle, but you can't go by looks. 43.4 degrees. The only thing that I can say about every one of these, they all better be less than 90 because every one of these are acute angles. Think about that one, okay? And do I want to do another one? Do I need to do another one? Are you set on those? I need someone to tell me if they need another one. All right, let's go down here then. If we have time, I'll go back up. When you see the rule solving right triangles, means that everything that's in that triangle needs to be filled in. Every side and every angle. So I'm looking at number 13. And I do see a right angle. And I do see a 72 as angle A. We would call that the measure of angle A is 72 degrees. But I'm missing the measure of angle B. Please, I hope you remember something in geometry. 38? That might be too big. Try again. No, 38 would be too big. 18? 18 is better. How did Nathaniel say the measure of angle B is 18 degrees? How did he do that? Say it again. What should all three of these angles measure up to? No, all three should be 180. There's 180 degrees in a triangle. But the easier thing is to say, don't worry about this 90. That means these two have to add up to 90. These two, Caleb, must add up to 90. So he gave me 72. So Nathaniel made the math and said it's 18 degrees. So let's go over here and label it. Measure of angle B was 18 degrees. Now notice how he's addressing the sides. He's calling them by their line segment that connects the vertices. So if I'm doing BC, BC would be the side that starts at the letter B, ends at C. It would be this side here. I would call that side A. Side A is the side across from angle A. So let me think. How could I find side A using what they gave me? Take a look at your paper. I'm going to erase my chicken scratch so that I can be thinking clearly. You're asking, can I zoom out
Yes, please.
infinitely?
No,
Just a little bit.
Oh, you said infinitely.
No, he said just
Oh, okay.
right there.
All right. I'm still looking for BC.
Need some towels, brother.
Right there. My advice to you would to use what they gave you. Don't use that 18-degree angle that we calculated, because sometimes that will be a rounded answer. And that would make all your answers rounded or off a little bit.
So a triangle equals 180.
The number of degrees added up inside any triangle is always 180.
So if we back together, that's 90. 90, 180 minus 90 is 90.
Who else is?
It's a 90 degree, which is a corner.
Yes? So you took the 90 minus the 72 and got the 18, right? So what trig function would use this angle A and this side right here? I didn't know anybody else was gone.
Oh, that's A. Jason.
Adjacent, thank you. I'll look at it as soon as I sit back down. You're out of testing?
Yes, sir.
Wow. All right, good job. Put SAT on there. So, yeah, he's right. That's an adjacent angle. So I'm given an adjacent angle, and I'm giving a 72. And this is what I'm missing. He called it, I think he called it BC. Fine, I'll call it BC. So making my trig function, what trig function would I use BC and the 15?
Stop touching me.
Caleb, you want to move up here?
Not really.
You're having a problem. And if you're not, you're giving me one. I got 15 and BC and this angle. What trig function uses those two?
So it's O and A.
O and A. That's right.
It's tangent or cotangent.
I'll use tangent. Tangent of 72 degrees
OA.
is BC. That's what I'm looking for. Divided by 15. Is that correct? So I'm looking for BC. So since this is a variable on the top, I'll multiply both sides by 15. Right? So therefore, BC is 15 times the tangent of 72 degrees. Pick up your calculator. Type in 15 tangent of 72 degrees, and what do we get?
I got you.
I haven't heard any female voices at all today.
Yeah, I think they're all a little tired, you know.
Well, it is hump day. We get past lunch. We'll be like on our way downhill. And then we can honestly say, oh my goodness, after today, only 2 days left. How much? 46.1 rounds to 2? Is this degrees or is this a measurement?
Degrees.
No,
No, it's a measurement.
it's a measurement. So I'm going to label it over there just for fun right here, 46.2. But I'm not going to use it since you probably rounded. I'm just guessing you probably rounded.
6.16. I forgot.
Goes on a lot, right?
No, it just goes on to 2 more.
Really? Interesting. So now I'm still missing the hypotenuse.
So it's A and B.
So you have two choices.
Use the 72 and
Brianna, stay with us.
Stay with us. You're dying.
If you got, we need to find the length of AB. You have two choices. You could use Pythagorean theorem because it's a hypotenuse, or you could use another trig function. What trig function would use the 15 and this missing side called AB?
Cosine?
Yeah, you're right, cosine. So find room somewhere. I'm out of room already.
Why not?
Cosine of the angle 72. Caleb, last chance.
Yes.
Whichever one of you starts talking the next time, I'm moving you up here. I don't know, I'm being punishing myself maybe, but cosine of 72 degrees is equal to the adjacent 15 divided by what I'm looking for, AB. So how do I find the 15? I'm sorry, how do I find the AB? I literally have to multiply both sides by AB and divide by the cosine. So if you allow me, I'm going to say this. AB is the 15 divided by the cosine of 72 degrees. I think so, unless I messed up. If cosine of 72 is 15 over AB, and I multiply both sides by AB, what happens? I multiply by AB, it's gone, multiply by AB. Then I divide both sides by the cosine. There you go, I get 15 divided by the cosine. That's what I have. So I think it's right. It just was a lot of thinking that I didn't want to have to do.
So is it 15 divided by the cosine of 72?
It is.
48.5.
It's 48.5.
40, approximately 48.5, and it's a measurement, right?
Yes.
And if you were to use Pythagorean theorem, you should get the exact same answer, 43.5. If you were to go, 48? Oh, 48 point. 48.5. If you were to go and do 46.2 squared plus the 48.5 squared,
Sir,
yes,
is that a 64
where?
that you put right there?
No, yeah. Oh, I was dyslexic. I've never been dyslexic before. 46.2 squared plus 48.5 squared should be, well, AB was what we just found. Wait a minute. I'm sorry, I messed it up. Isn't AB the hypotenuse?
Yes.
So that can't be the right. I would have messed up on Pythagorean theorem. It's the leg squared. Yes, 46.2 squared. 0.2 squared. Plus the other leg, which was given, 15. All right, that's easier. 15 squared. Should be the answer we just got, the 48.5 squared. Should be true. Okay, so if you would have solved it for C, you would have found that. All right, let's jump to number 15. I'll try to write smaller. Oh, man. There's no angles. Well, that's depressing. Can I use a trig function and use an inverse if I have the 8 and the 7.6? What if I want to find angle L right here?
That's
What if I find angle L?
J and L is
A, you're going to call that an A, yeah.
the 7.6 is O,
Yeah.
and the 8 is a H.
You really got this. Who's talking?
Carlos.
The guy who was absent a lot?
Yes.
Man, you're pretty awesome. Yeah. You were absent a lot and you caught on right away. I'm very impressed. So, what trig function would use the O and the H to find angle L or theta? Inverse sine. So I'm going to write sine first. Some of you will just cheat and go inverse sine right away, but I'm not good enough. Sine of angle L. I'll call it theta.
So can you scoot it up a little bit?
Up or down like this?
Yeah, like that.
Sine of theta must be equal to 7.6 over 8. Oh, good. I don't have to move anything funny. I just got to say inverse sine of 7.6 over 8 must be theta. Okay, we're going to get theta. I'm excited. What is it going to be? What is my theta? 71.7 or 8? 8 what? Degrees, yeah. Let me go write that. That was angle J. Let's see if they have it called J. Measure. Wait, they're looking for K and L. Was that J? It was L, sorry. L. 71.8. Now, is there a fast way to get the measure of angle K?
Yes.
How? You could do trig. You could do trig if you want. But what do you know about all three of those angles? What do you know about J, K, and L? What do they add up to? 180. What do you know about K and L by themselves? K and L.
It's 71.8.
Where'd you get that? No, wait. L is 71.8. But what do you know about K and L together?
J is 90.
J is 90, yeah.
And so you just add those and then subtract that from 180.
Yes, you can do that.
And you get your answer.
You can do that. How much? 18.2. He's fast. I personally would have just taken 90, subtract 71.8. And that gives me the exact answer, I think. Yeah, 18.2. So 18.2. Yeah, these two have to add up to 90 degrees. Because they're two acute angles besides that right angle. Very good. All I'm missing is a side, according to him. JL, let's see, where's JL? Oh, yeah, JL's the bottom. Right here. Yeah, JL. So what trig function uses the two numbers that they gave me? I mean, I don't need both sides. I do need an angle. Sorry. Which angle do I need to use?
L.
You want to use L because it's written right here, 71.8? Okay, and then that would be equal, what I'm looking for this side right here, would that be the adjacent?
Yes.
And could I use the hypotenuse? So what trig function uses adjacent and hypotenuse? Oh, good. So cosine of, I have to use the answer we did in our calculator. I don't like to do that, but I have no choice because they didn't give me any angles. Is equal to
Wait, what's that number above 8?
degrees. Equals to adjacent, which is JL, over hypotenuse, which was 8. Is that right? I don't want to go too fast. I want you to look at it and agree to it. Because once you understand where I got those numbers and why somebody said cosine, if you don't know why somebody said cosine, ask us.
You could remove the 8 and put it in front of cosine.
Well, he's trying to get the answer already. I'm trying to get everybody on the same wagon. Come on, guys, all jump in. All right, if you don't say nothing, I have to assume that you got it, all right? He's already ahead of us. So he's going to multiply both sides by 8. Therefore, 8 times the cosine of 71.8 degrees must be JL, and he's already done it. JL, he says, is, did anybody else get 2.5?
Sir.
Yes. Say it again. Should it be tangent? Of K? Yeah. Of K. Yeah, that was another way of doing it. He decided to use the adjacent and hypotenuse. You're wanting to do tangent. That's the problem if you, tangent's fine, there's no problem. You could have said tangent of K is JL over 7.6. You're absolutely right. And so I'm going to finish this up so you can see it's the same answer. K was, well, we did it over here, K was 18.2. Because you're using the other angle, so therefore it makes sense to use a different trig function. Very good. That's impressive, Anthony, that you looking at it a different way. That's what makes math hard sometimes, because you see, well, I could do it this way, I could do it this way, I could do it, and you're wanting to say, just tell me the one way to do it and don't mess me up. Well, I'd love to be that person, but it's the best way is the way that you see it. So if he saw that tangent, and I forgot the angle, 18 point what? 2, okay. Tangent of 18.2 is JL over 7.6. So you're going to do 7.6 times the tangent of 18.2 will be JL. So key that in, Anthony. Let's see what you get. What do you get for JL? Are you keying it in, Anthony?
Yeah, just give it a moment.
He's revving up the motor? Warming up the car? What'd you get? What'd you get?
It's like a moped. You have to give it a moment.
Yeah, really? What'd you get? Louder.
2.3.
2.3. What'd I get over there?
2.5.
Oh, how are we off a little bit? Oh, maybe when we did the 18.2, did we round somewhere? Oh, okay. That's the only issue. Is when you take a rounded answer, you're going to get different answers for the different angles because it's a tough call. I wonder, was there any way that yours could have rounded to 2.5 or even a 2.4? You said it was the same answer, though. Did you?
It's the same answer.
Well, we got 2.5 over here.
I did it as well as 2.5.
Oh, what happened, Anthony? It's not a 2.3, sir? Did you type in 7.6 tangent of 18.2?
Oh, whoops. I pressed 7.
Yeah, it's the same.
Okay.
It's the same thing.
Okay. Okay, good.
That's 2.349.
Yeah, okay, good. Good. I'm glad. I mean, you did good. I'm proud of you. That was just a lesson to us all that, wow, you can literally do it with a different angle, a different trig ratio, as long as you're using pieces that you have. Let's go to 16. Let's see where we're at. We might have time to go back up if we wanted to. Again, he didn't give me any angles. So I need a trig function that uses those two sides. Let's use angle D.
O and A.
O and A. Tangent of D is O over A, which is 22.5 over 21. 22.5 over, is that a 21?
Yeah, it's 20.
All right, so this is using an inverse tangent now. Inverse tangent of 22.5 over 21 is what angle? And I'm going to label it. You should all be keying it in. You guys that are not doing it, and you don't pass the quarter, you'll know why. Because you're not being serious. Got to be serious every day.
47.
Oh, it goes to 47. 47 point what? 0. Make sure you say 0.0 degrees. That would be right here, 47.0 degrees. Do you want to do trig again to do F? Or do you want to do the magic, subtract that answer from 90? Yeah, I would take my calculator and do 90 minus the previous answer. And what do we get? 42. 43? 40, it's 80. They have to add up to 90. You're right, it is 43. So angle F is 43. And angle D was 47. I'm going to just put 47. We're missing one side. We're missing the hypotenuse. So pick the side you want to use with the hypotenuse. I would agree with you. I'd rather work with 21 than to work with a 22.5. So what side is that? What angle are you using then? You're using an angle D?
Yes, we're using 47.
All right, so I got D and these two sides. So cosine of D must be 21 over DF. And D is 47, right? Cosine of 47 is 21 over DF. Multiply both sides by DF. I'm going to show the whole step. DF, cosine of 47 degrees is 21. Divide both sides by cosine of 47 degrees. Cancels. DF is 21 over the cosine of 47 degrees. Go ahead and type it in. Oh, by the way, I wanted to take a grade based on your notes today.
Okay.
All right.
Yeah.
Cool. It's 30.8.
It is 30.8?
30.8.
30.8. All right. And next